Hello, welcome back. So today, as part of this data modeling masterclass series, we are bringing up another video, which is again one of the basic concept, and it is very important to understand this concept. So that is, what are the key elements of logical data model? So we have seen like there are different kinds of model, right? There is a conceptual model, there is a logical model, there is a physical model, right? So like there's a different levels of model, and each modeling captures like different levels of detailing, right? And logical data model is one of that. And so most of the, like if you are an architect or if you are a data engineer, if you are a database administrator, basically if you are a technical person, so logical understanding data modeling is very important, because most of the time you either you do it or you might use this logical data model to actually implement, right? And so we will just quickly go through what are the key details or key elements of the logical data model in this video. So before proceeding, if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So as you can see, key elements of logical data modeling, right? So we have entities and attributes, we have relationships, we have primary and foreign key, and lastly we have this concept of normalization. So you might have already heard about these things. But as part of this course, we want to cover from like a cover all the from the beginner level to advanced level. So we want to cover all the details in a particular course, as a particular course, and we want to cover all these details in a uh, like in a sequence, right? And that's why we will, if you're not aware, so then you can just get use of this understanding in this video. So let's go one by one about these entity relationships, entity and attributes. What are the relationship between entities and relationships? How do you define a primary and foreign key, and what is the concept of normalization? So right. So the first concept is entities and relationships. So entities and attributes, sorry. So entities and attributes is nothing but actually it's so if you talk about entities, right? So it is represents distinct objects or concepts within the domain being model. So say for example, you are building a retail management system, right? So and you want to, so retail management system, if you take a like Amazon or like a Flipkart or something like that, right? So it will be very complex. There might be hundreds and thousands of tables in that database, right? So in that case, you cannot define a table called customer, right? There might be a table called customer. Again, you cannot define a same table again, because it will be a duplicate, right? So that is why we say a distinct object. So if you are naming one table as customer, so another table cannot be named as a customer, right? So we need to be carefully choose the words, right? And so you can, maybe you can create a customer like underscore some region, right? So customer underscore India, customer underscore US, customer underscore UK. So you can design customer table, but end of the day there should be a distinct objects, right? Or the distinct tables within the domain. And so it can be, right, so customer, product, order, right? So transaction, any table you want to capture, like inventory, whatever in the retail system, if you want to consider, right? Basically entity is nothing but it is constitute to a table, right? If you see physically, so this is nothing but a table in database. Okay, and that's why it makes sense to have a unique identifiable name for it. Okay, and so next is attribute. Attributes are the property or characteristics of an entity. So that means without entity, their attributes will not be there, because entities gives the properties. Entities are the properties or characteristics of the entities. Suppose there is a customer, right? And so customer entity might have attributes like customer ID, name, address. So it actually entity is object, right? It's a physical object. Suppose customer is a physical object you have taken, right? And to define what is customer, right? So what are its characteristics? So that will be known or defined by the attribute. That means a customer can have like as it's mentioned, customer ID, name, address, pin code, date of birth, whatever, right? So you can think of many possibilities of the columns that you want to capture in this particular table. So that is what we call it as attributes. So and attributes so are nothing but these are nothing but columns in database management system. So this entity is a table and attribute is a columns, right? And so entity basically there are different characteristics of entity. So and there are different types of entities. So there is a strong entity, weak entity, and so all those things we will discuss in the next video in detail. And in attributes also there are different characteristics of attributes and types of attributes. So we will discuss that in upcoming videos in detail. But this is a basic video, so hope concept of entity and attribute is understood, right? And next, what is relationship? So relationship defines how entity interacts with each other, right? So now whatever we also saw, right, there is a customer table here, right, and there is a order table, right? So customer table, what is this table? What we are calling it as a entity. So this is an entity, and order table is also entity, and internally they have what attributes. So this is a customer name, customer ID, date of birth, location, whatever. In the order also order ID, what is the product, date of transaction, amount, whatever, quantity. So that also is a these are also attributes. So uh, each entity that is customer entity and our or order entity have its own attributes here. So that is clear, right? And now how this particular customer entity is having a relationship with the order entity. Okay, so think it logically, right? So you need to think very logically here. Suppose you are a customer, a particular customer, and how do you interact with the order tables, right? Customer places the order, right? So that is why, and there can be a different specification of cardinality. Example, there can be one to one and many to many. Okay, and can include attributes like order contains multiple products, etc., etc., right? Suppose one to many. What is one to many, right? So one to many is like, so if I make it order to customer as one to many, this is one to say n. I make this is one to n. That means one customer can place n number of orders, right? That is a one kind of a relationship. So that I want to define here. So that is a valid kind of a relationship, right? And suppose there is a product table here, right? This is a product and this is another entity. So between order and product, you can have many to many, M to N. That means many to many relationship. That means multiple orders can have multiple products. So it's like there is a one product here, and this product might be one order here, and this order can have multiple products. And similarly, a particular product can be placed in multiple orders. So it's many to many, right? And this is what we call as a cardinality. Again, we will discuss this cardinality concept in detail in upcoming video. And what is primary and foreign key? So primary key are unique identifiers for each entity instance. For example, customer ID could be a primary key for customer entity. Like there is a customer entity here, the customer table, and there is an order table here, right? So if let's imagine you don't have any ID, right? Suppose there is a first name, last name, and location, and his address, whatever, right? But you don't have the ID itself, right? ID is something like, suppose if you are in a US, you have a social security number or something, right? And if you are from India, like you have some Aadhaar card, right? So that uniquely identifies a person. So if you're not able to uniquely identify a person, so you cannot do any record management, right? So that is why it is important to maintain a or have a ID for each customer. And for that matter, if there is any entity, and each and every entity should have some or the other keys, so to uniquely identify the records. So that is one of the best practice. And especially like if you are having a customer and order kind of a table, so you need to uniquely identify them, right? So that's why you need to have this kind of a IDs and even order, right? So whenever there is a new order, so there should be order ID. So whenever there is a customer ID here, right? And there is a order ID 1. That means customer 001 has placed order 01, and again he can place one more order 02. He can place one more order 03. So whenever he places order, so there will be a order ID automatically generated, or you can define it as a surrogate key or whatever. So that uniquely identifies, right? And so this is again a one-to-many relationship. So again, whenever it is a primary and foreign key, so it is having a relationship. So without a relationship, there is no concept of foreign key. Foreign key means there are at least two entities which are interacting, and so one key is being referred by other key. That means here the customer ID is referred to the order ID. That is one to many relationship. One customer can place many orders. So foreign key are the attributes that create a link between the two entities. So that's again, right? So this is customer ID is a primary key in this table, and order ID is primary key in this table. Okay, right? And but what we have done is there is a customer ID also in this table. Okay, so by creating this customer ID in the order table, so what you are actually making is that means whenever an order is placed, so there will be order ID and customer ID. Order ID though it is mandatory, right? So it will be there, and customer ID is extra column that you are adding, so which will be called as a foreign key. So foreign key is what which will link these two tables. So without foreign key, you cannot have one to one, one to many, many to many. None of the relationship will be established without a foreign key. So primary key is within the table, and foreign key is one of the key in the secondary table, so which will link the main table. So hope this is clear. So next we will move to the another important concept, that is normalization. So normalization is actually a systematic process of organizing data in a database to reduce the redundancy and improve data integrity. So please note the point, right? So it should um, the main intention of normalization is to reduce the redundancy or eliminate the redundancy and ensure the data integrity. And it involves a decomposition of the tables. So what you do here is you decompose the tables into smaller tables and related tables without losing the data. So you actually decomposition is nothing but a big table is there, and there are like 50 to 100 attributes, that is columns in that table. So instead of keeping all those columns in one table and having one big table, so you actually decompose it into a smaller tables. So the main goal of normalization is to minimize the duplication and dependency of the data, and to ensure the data is stored efficiently and consistently. So the data should be stored efficiently and consistently. So that is there. But why do we need to do that? So why do we need to store the data efficiently and consistently? So the reason is it will store it'll first of all it will save the cost of the data by removing the duplication. But the main reason is so if you make the proper normalization, whatever reports or analysis or analytics you run on top of this data model, so will be much faster, because so it will decompose into multiple tables, right? So it knows like there will be not a much of a processing delays in terms of getting the data in the reporting layer. And so the key concept of normalization basically, as we said, right, redundancy is there. One thing is definitely the redundancy. So redundancy is one thing. So repetition of data within the database which can lead to anomalies and inconsistencies. So that will be removed using normalization. And the other thing is anomalies. So what is anomalies? Anomalies is nothing but it's a problems, right? That arise from redundancies that might occur, and this can happen during the insert anomaly, so difficulty in adding a new role, new data due to missing other data, right? And if you want to update anomaly would be there, so where you have an inconsistency arising when updating the redundancy data, because so you go and try to update a employee table, right? But there are two employees, okay, because there's a redundant. Or if you go and want to update a location pin code, but there are two locations, which location pin code need to be updated, so that is update anomaly. And similarly delete anomaly, like so you don't know which record to delete when there is a multiple redundant records. So this will lead to a lot of issues, right? And that will be solved by using a normalization. And normalization, there are different forms of normalization, that means level of normalization we can call, so is achieved through a series of rules called normal forms. So normalization basically can be achieved using normal forms, so that is what we call as a normal forms. So normal forms make sure that your normalization is implemented. So, and when you talk about normal forms, there is first normal form, okay, and there is a second normal form, 2NF, right, and there is third normal form, 3NF, and there is also called as something called as BCNF. BCNF is nothing but BOC code normal form, right? And there are higher normal forms also, like there is 4 NF and 5NF normal forms, which are again rarely used. And we will discuss about normal forms in detail in another video. So, but hope you understood the why we are doing normalization. So that need to be clear in this particular video. Yeah. And steps in creating a logical data model. So as you see, there's a requirement gathering. So here what we do. So requirement gathering is a important step where we take the requirements from the business, we document it, right? And understand the business requirement and the scope. And this involves you can have multiple level of meetings, workshops with the stakeholders, analyzing the existing system and review the business processes. So that's the important step in first step in creating a logical data model. So once you have those requirements, so you create a conceptual model. So conceptual model we have discussed in the previous videos. So what it does is it creates a high level model that defines the main entity and relationship without so here in this conceptual model you will not create a detail uh, say like detail attributes tables, so there might be hundred of table, but in conceptual model you bring only the important tables and only the important attributes for each of the tables, which are like which help in business discussions. So that's building a conceptual data model, right? And then you have define entity and attribute. So that's what we have seen in the previous slides, right? So detail each entity with its attribute. So you need to have customer table, order table. So you need to identify how many entities that are needed here in this step. Suppose a business says they want to implement a say for example a retail platform or healthcare system. So to define a healthcare management system, so what are the tables that you need, right? So there is a patient table, there's a doctor table, there is a medicine table, inventory table, instruments table, whatever, right? So these are all the entities and how these entities are related to each other, right? So that is defined in the relationships in the next step. And once you define it, whether it might be a one to n, one to one, one to n, many to many, so what kind of relationship it actually logically holds, so that you need to kind of a clearly define. And once you have that details, further you try to normalize. So normalization, as you saw, like it has a lot of advantages, and it removes the duplicates, it brings the performance, and so applying normalization rules usually up to the third normal form, right? So we have fourth and fifth normal form, but that are very rarely used. So one, two, three are the three normal forms which are exhaustively used in most of the cases, and you need to you understand one first normal form, second and third normal form, and make sure that ensure that the logical data model is free of any redundancy or any kind of anomalies, right? And the next one is we define a primary key and foreign keys. So like when you're defining a relationship itself, so there might be already defining a primary key and normal key, but once you do a normalization, so again you might need to redefine the primary key and foreign keys, because you have done the normalization, and the tables might have 10 tables might have become 20 or 25 tables now, and you need to redefine the primary key and foreign keys, right? And the final step is where you validate the model, in the sense you review the logical data model with stakeholders. So you show that, okay, this is my logical model. You go with the architects, you discuss with the stakeholders, business users, business SMEs, and you also discuss with project managers. So you bring all everyone into the everyone into one page, and you discuss that, okay, everyone's understanding is meeting in this logical data model. So that's the whole intention of creating a data model, right? And so by the time now you might have already understood the benefit of data model. So it's bringing the clarity, because if you are talking about the complex implementation, and without the logical data model, you don't know what to talk to a customer, you don't know what to implement, you don't know what happens if I want to enhance this or update this, right? And you don't know how to document it. So all those will be removed, and it provides a clear and detailed structure of the data requirements without worrying about how it will be physically implemented. So here you are not even thinking about how it is physically implemented, right? It might be implemented in database, SQL, Oracle, NoSQL. You don't care about that at this moment when you're designing a data model. And next is a consistency. So ensures the data integrity and consistency across the system by defining relationship and constraints. Because you have defined the relationship, you have defined a constraint. Suppose you have defined a, say for example, a customer can place an order, that is one to many relationship. So in this case, you always see a order cannot be placed without a customer, because there is a constraint, because there is a foreign key constraints in the order table. So foreign key constraint in the order table, which will be having a customer ID. So order table will have customer ID. So without a customer ID is being available, so the order will not be created. So that is a constraint that you are creating. So if that constraint is not there, it will lead to the data inconsistencies. And similarly, you can say there is a patient records management system, and you have a invoice generated for a patient for his treatment, and say for example patient ID is missing, right? And if the patient ID is missing, so then you cannot actually correlate with any other table, or you cannot derive any relationships for that particular transaction that happened, right? So you will need to make that patient ID as a primary key or mandatory column as a not null column. So that's again will help in the maintaining the consistency. And also scalability. So when you talk about scalability, so scalability is nothing but it makes it easier to scale up and adapt the model to the feature changes or the requirement, because we are in the most of the projects are agile, and so your model should be scalable enough, and if it is properly documented, you can have everything in page. So whenever there is an enhancement or change, you can come to that document and you can make the changes. And finally we have a foundation for physical data model. So this will the logical model, as we said, the first step is conceptual model, and next comes the logical model, and the final we after logical model we go to the physical data model. So so we are in the middle, right? So that is a logical data model. After logical data model, so the next step is physical data model. So that's why we are calling it as it acts as a foundation for physical data model. That is next step. So it serves as a blueprint for creating the physical data model, and also guiding the database design and implementation related details here. And finally, we will understand what are the tools that you can use for logical data model. So you can use the ER Studio, and a data modeling tool for creating and managing a logical and physical data model. And you have a Microsoft Visio. So it's again one of the famous tool, Microsoft tool, often used for creating ER diagrams, a key component of logical data models. And you have IBM InfoSphere for data architect and enterprise tool for creating logical and physical data model. So there's Oracle, skilled developer data modeler. This is also a tool for designing and managing logical, relationship, physical, multi-dimensional, and data type models. So these are the some of the tools that we have compiled here that can be used to create a logical data model. So are the tools mandatory? So no, tools are not mandatory, but so these tools are enterprise tools, and it's not just of creating a 10 to 15 tables you have and you do that in the Microsoft Word or PPT, so that we can anyway do it. But so when you talk about a enterprise level project which is having hundreds of tables, hundreds of relationships, so then you cannot really make that in possible in the Microsoft Word document or any kind of PPTs. So it will be huge document, and you need to have a lot of tools will actually help you here to make your life easy. Okay. And so hope this introductory video regarding entity like logical data model, what are the steps, what are the basic entities, basic components that we use in logical data modeling, why we use logical data modeling, what are the tools, what are the benefits, so that we have discussed in this video, and hope this was useful. Thanks for watching.